When we talk about code modernization, the first thing we need to address is that your application needs to take advantage of the existing resources. This is going to include advanced resources on whatever system your application happens to be running on, such as multi-core processors, large caches, high-speed memory, high bandwidth, interprocessor communications, and high-speed I/O. The first stop in code modernization, and in my opinion the easiest way to squeeze a lot more out of your application and adapt it to whatever your particular system is parallelization. This is the process of parallelizing processes and splitting the load among multiple processors. So this actually can enable applications to run in a lot less time. Say, for instance, you have an application and you haven't addressed this issue of parallelization, and maybe you have, say, a for loop that's doing a lot of stuff and a lot of gnarly math or something. So if you haven't structured it so that it runs in parallel, it will actually run sequentially. It'll do one loop iteration at a time. And if you've got a lot of data to process, and if you've got a lot of, say, gnarly processes to do, such as maybe a lot of math, then it could really take a lot of time. But if you parallelize it, here again, you're splitting up the work, and it's going to go that much faster. Maybe you have eight cores or 8 processors, and you can split it up amongst the 8 processors. It can enable applications to process multiple sets of data. Say, for instance, one core can process this set of data, another core can process this set of data, and so forth. So either you split up one data set amongst multiple cores, or you can use a core for each one of the different sets of data. And the last point I'd like to make is that this lets applications process really big data sets that otherwise would just be prohibitive to run because they take too long, or potentially tie up your computing resources too long. So here's the first case I mentioned. Here we've got this loop. I think it goes through 10 million times, and it does some pretty gnarly math here. So this is going to be a sequential loop. It's going to do, when I is 0, it does this. Then when I is 1, it does this. Then when I is 2, it does this. So it's really kind of gets gummed up because it's totally sequential, and it's going to take a lot of time. But I can decorate this with a compiler directive that instructs the compiler to separate this into different threads to perform this operation. What the compiler does is it adds code that dynamically adjusts to whatever the system is that it's running on, such as how many cores you have, how many cores are free, how many cores are not really bound up by other processes. So in real time, it dynamically figures out how many threads to split this up into. Now my computer has 8 cores, so it will give me at least 4 threads. It will split this up into at least 4 threads, and more like probably 6 threads, because nothing's really going on in my system. And this will significantly reduce the time it takes to do this loop. So this is the second case I was talking about when I first started this presentation. And you don't see a for loop here. Basically what you see is the creation of 2 different threads. And these 2 different threads are going to process 2 different data sets. So I create the threads, it spins up and kicks them off. And then I just wait for them to be done so that the program doesn't end before the threads are complete. So here, notice that I have 2 data sets, 2 data arrays. This first one does the exact same thing I did in the last example, except without the OMP pragma. And so the reason I didn't use the OMP compiler directive is I just wanted to make sure that I was clear on the concept of this. So the second function does something similar except slightly different. So here I have 2 data arrays and 2 slightly different calculations. So in conclusion, You need to say that code modernization, the basic tenet is that it starts with taking advantage of resources. And my suggestion when you're getting started is to make the first place you look and study is trying to parallelize your application.